So we'll do a little quiz. I don't remember what it is, but I know we haven't done 6,999, so I'm going to say 7,000. I think it's like 6, but you know. Quiz number 7,000 for ternary transformations, but I feel like it is quiz number 7,000. Okay. Determine the transformations when y equals 3, x plus 2 squared minus 6 is transformed to y minus 3 equals 6x plus 1 squared. So we're going from a quadratic to a quadratic. So you have to actually literally look at the first quadratic and see how you have to move that one to get me to my new quadratic, right? Quadratic to quadratic. Number 2. All right. So 1 and 2 are similar questions asked in a different way. If you look at number 1, it says determine the transformations when y equals 3, x plus 2 squared minus 6 is transformed to y minus 3 equals 6, x plus 1 squared. So we are going from a quadratic to a quadratic. We are going from a graph of parabola to a new graph of a parabola, and we have to see what we have to do to the graph of the first parabola to move it to be on top of the graph of the other parabola, right? That's what 1 is asking. So the first thing I'm going to do is minus or add that 3 over so that they're in the same format. So now I have y equals 6, x plus 1 squared plus 3. If I have in the same format, I can just compare them now. Three to 6. What am I doing? Vertically stretching by a factor of 2. Can we do this on the unit test? write it like that? The answer is no. You have to write vertical stretch by a factor of blah, 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 right? Okay. If we stretched it by that factor, now some people will be like, well, do I have to apply it in? What do I have to do? How do I undo it? What do we have to do? Well, let's see. So if we just applied that to this graph, okay, we have to apply it, right? We have to apply that vertical stretch, don't we? So let's apply it. Because when we did graph to graph, remember when we did graph to graph, what did we do? We found out what the stretches and reflections were. We applied them to the graph, and then we figured out what we had to do to move it on top of the other one, didn't we? So the same thing has to happen here. We realize it's a stretch by 2, so we have to apply the 2. So we're going to get y equals 6x plus 2 squared minus 12. So that's our in-between equation, right? Just like when we had graph to graph, we had an in-between graph, and then we horizontally translated and vertically translated, correct? So we figure out our stretches and reflections first and apply them to our original. Now, once we apply those, we can do our translations. If we don't, we're going to get a vertical translation or horizontal translations wrong every time. This horizontal one won't affect because I don't have stretch in there or reflection. So, it's not, some people will say, well, I'm at -6, I'm at 3, I moved 9 up. That's not true though, is it? This is my in-between equation once I applied my 3 to it. So now I'm going from that to this. So I need to get to here. So I'm at -12. I need to get to +3. What am I doing? I'm at -12. I need to get to +3. Where am I going? Up? How many? 15. So vertical translation, 15 up. Remember, we can't write short form. We can on a quiz because you're looking at it, right? But anything I'm marking or a diploma person is marking, we write full out. Except for LS, RS. That is the only thing I will limit you. Okay. Our horizontal translation wouldn't have been wrong anyways because the vertical stretch only affected the vertical translation, right? So we were at -2. We were at -2. We're now at -1. We move 1 right. Correct? So does that make sense how you have to apply it first and then move it, or your vertical translation will be wrong? Okay. If you're someone who made that mistake, which I'm expecting it would be, because I haven't went really over these ones in hardcore. We went over them in graphs, but not as much in equations. I would highlight it. I would star it. I would make sure I go back and look at it, right? Okay. Number 2. Given the original function is a quadratic, determine the transformations when the function of g of x, the transformed function g of x, when g of x has that happen. This is different. So you see this? We went from a quadratic to a quadratic. We agree? This time, we're going from a quadratic. This is just a way of stating the transformations without physically writing them out. I could give it to you like this. See, do you see it has the little f in it? So it's saying, I'm doing these transformations to f. That's what it's saying. We're not saying, oh, how far does it take me to get from here to here? This is just another way of writing the transformations out without literally writing vertical stretch by a factor of 3 about the x-axis. Horizontal translation 3 left, vertical translation 1 up. So if we go from a real equation to one with an f in it, then when I'm saying, oh, my real equation is f of x, I'm doing this to f of x. That's what it's saying. So instead of giving it this way, I could have given you mapping, and you'd have to apply it. Or I could have given you words, and you have to apply it. This is just a third way of giving you a different way of telling you what the transformations are. Because I have the f in it, my original equation was f, I'm just doing this to that. So some people will go, oh, I'm going from 1 to 3, how far is that? No, that's not what you're doing, right? That's not at all what I'm doing. This is my original equation. I'm happy about that. But from here, what I'm pulling is transformation. So I'm pulling a vertical stretch by a factor of 3 about the x-axis. Horizontal translation, 3 left. Vertical translation, 1 down. Okay? So when we go from a real equation to one with an f in it, so a real f of x equation to one with an f in it, they're just giving you transformations without writing them out. That's it. You see the difference between 1 and 2? They're very different. 1 is a quadratic to a quadratic. How did I get from one to the other? Figure out my movement, right? This one is a quadratic to, I gave you the function with an f in it, now you have to transform it. So, we're going to go, I'm going to rewrite that f of x equation. F of x equals 3x plus 1 squared plus 2. I just moved the 2 over. And now I'm going to apply my stretches and reflections first. When I'm done that, then I do my translations every single time, right? So this throws people off, but it's literally just the way they can write it without physically writing what the transformations are. We're giving you mapping. That's all it is. So I'm going to apply my stretch first. I'm vertically stretching by a factor of 3. The whole equation, remember? So it affects this and this. So I'm going to get f of x, and it's not f of x. Now it's what? G of x, right? That's what I'm changing it to. So it's g of x equals 9 x plus 1 squared plus 6. Right? But we're actually moving it 3 to the left, so it's not x plus 1. What is it? It was negative 1, and now I'm moving it 3 to the left, so it's actually, it was 1 to the left, I move it 3 to the left, so I'm now 4 to the left, right? So this is x plus 4. Oh, I don't have to erase. I can just turn it into a 4. I'm 6 up. I need to move 1 down. I'm actually going to be what? 5. So once you apply your stretch, you can apply your translations in there too, right? Do you get the difference between 1 and 2? Do you see the big difference? Because it is. It's 1 is you're going from one to the other. How do I get there? 2 is I have an equation. I gave you transformations in a weird, funky way. Apply it. 3, the range of the function is from 3 to infinity, which means x such that x, what am I talking about? Y such that, what am I talking about? F of x such that, because y is not y is f of x. F of x is greater than or equal to 3. F of x dr. I just wanted to show it to you in set notation so you could see both. Okay? You didn't have to do that, right? If it's in interval notation in the question, they're expecting interval notation in your answer. All right? I'm just showing you set notation just so you can see it. And to remind you that if it's f of x, don't write y. We have to write f of x. That's what our variable for y is. So f of x is transformed into h of x. H of x equals negative 3 f 2, I can take the 2 out, x plus 3 minus 1. Now here's one of those situations again. I went from a certain f of x, I'm now going to an h of x with an f in it. What does this mean? They stated the transformations to me, that's all it means. Right? It's another way without saying the words. So, this is only range. If I had forgotten to take the 2 out, would it even have mattered? Because the x doesn't matter, right? Well, I'm swapping markers here. That's crazy. This is what affects my y. Because if I draw it, it makes a y. It's also not with the x. It doesn't affect the x. So if I wanted to do my mapping for that, I would say that I'm going to take my y, I'm going to multiply it by negative 3, and I'm going to subtract 1. That's what I'm going to do to my y. Do you agree? So I have to do that to my y. The only y I have is this number 3. So I'm going to go negative 3 times 3 minus 1. And I go negative 9 minus 1. And I say, oh, my new number is negative 10. Awesome. So my range is this. Negative 10 to infinity. Perfect. And I picked that one, and we're sad. We are super, super crazy sad because that's not actually the right answer. What did I do? Yeah. You have to flip it around because what happened? There was a reflection. This negative not only changes this 10, it makes this a negative 10. We agree? But it was, it was something like this. It was greater than 3. We agree? It's now at negative 10, which is great. But if I said greater, is it actually reflecting it? No, it's actually has to be now less. So remember that when we have negatives in front, it does affect our number by multiplying it, but it flips that inequality sign. So this isn't actually right. It's from negative infinity to negative 10. Okay? If you're someone who's still forgetting to flip it, which is often what happens, leave yourself a little side note. Star, star, star. Highlight, highlight, highlight. Right? Because that's the number one error. People will remember to get the number. The other error is I gave you one that had an infinity in it, which was me being nice. Because if I do this, say I went 3 to 7, people will write out mapping, and they'll put this in the x, and they'll put this in the y. Do we do that? No. We would put this in for the y, the 3 in for the y, here, and we put the 7 in for the y here, and then our answers would actually flip because of the reflection. And it would be obvious that you should flip them because it should go from low to high, right? If you don't remember to flip them, you're going to be going from high to low, which doesn't make sense. You have to list your numbers from low to high. Make sense? Okay, we're going to go to the notes from yesterday. So here it says, for example, 5 is the last thing. So what did we went over in polynomials? In polynomials, we start out with factors. We factored degree 3s, then we factored degree 4s and 5s. Then we went over solving. How do I get what the actual x is? When I solve, I'm determining the x-intercepts, right? So if they ever ask me for the x-intercepts algebraically, I'm going to have to factor, then solve. The next thing we did is we went over graphs. What the heck do graphs look like? If the leading coefficient is positive, it's up on the right. If it's an odd degree, it's in the opposite direction on the left. If it's an even degree, it's in the same direction on the right. My constant is my y-intercept, right? We went through all those things. Odd degree functions are xer, yer. Even degree functions are xer, y is greater than or equal to if it's a minimum, y is less than or equal to if it's a maximum. The maximum possible number of x-intercepts is equal to the degree. This is also something we should think about. Odd functions, so x to the 1, x to the 3, x to the 5. If we do possible, oh, where did that go? Possible number of x-intercepts for these ones. For x to the 1, I have at maximum 1 x-intercept, and that's it. It's going to cross through, right? It's a straight line. At some point, it crosses through. Okay? X cubed has at most how many? Johannes? Then it could have 2. It could have 1. Could it have none, an x cubed? If the arms are discoing, remember they're discoing. One is up, one is down. Is there ever a way that I can't ever cross through that x-axis? No, at some point it's going to cross through. So minimum I have is 1. Degree 5, maximum I have is 5, 4, 3, 2, 1. Could I have 0 again with that x to the 5 because it discos? Nope. Arms are in opposite directions. It's going to have to cross through somewhere. Right? Now, counterpart, the evens. X squared, x4. X squared, Spartacus, what does it have a maximum of?
2.
2. 1, could it have none?
Yes.
Why?
It either opens up or opens down.
It either opens up or opens down, and therefore
It could have no x's.
Because it could be completely above, or it could be completely below. Yeah. Degree 4, Jacob.
4.
Then?
3. 2. 1. 0.
And it can have 0 as well, right? Because it can make W's and M's. And W's and M's, technically, can be completely above or completely below. So when those arrows are in the same direction, we know that there's a way that that graph could actually be completely above or below and have none. But when they disco, when the arms do something like this, no matter how many floppy, flippy flops I have up there, it's going to have to cross through at some point. It's going to have to have a minimum. Okay? So then, the last thing I told you we were going to go through is determining equations of a polynomial. Now, you determined equations of a quadratic last year. If you were given the vertex and a point, you could solve for the a value and you could get the quadratic equation by plugging it into that a x minus h squared or x minus b squared plus q. Maybe probably was the format you were given. When we're doing this, I want you to type this into your calculator first. Y equals x plus 1, x minus 2, 2x minus 3. Please type that in. X plus 1, x minus 2. So we have x plus 1, x minus 2, 2x minus 3. Is that what I said? I'm going to take that as a yes because no one is correcting me. Ooh, that's an x. Is that what it was? So it looks like I have x-intercepts at -1, 2, and what's this one at? 1.5, 3 over 2, right? Because we'd solve that 2x minus 3 out, move the 3 over, divide by 2, 3 over 2, 1.5. Boom. Okay, let's do this now. Keep that in y equals, in your y1. In your y2, I want you to put a vertical stretch in front of it. So a 3, and then retype it. We're just putting a 3 in. A vertical stretch. It's the exact same equation. All we do is put a vertical stretch in, right? Let's press graph. Now what I want you to do, if you have a negative 10, 10 window, I want you to be able to find the y-intercept. So we can see everything on here, but we need to go higher. So we're going to go in our window and we're going to make our y max bigger because I want to see it. So I'm going to make it be 30 and see if that helps. Did my x-intercepts change? Nope. My x-intercepts are still the same, correct? Why would they stay the same? I added a number. I gave you a hint. Yeah.
You solve for the x's, they're still the same.
You solve for the x's, you're still the same. What number did I add? I added a 3. What transformation is that? Yeah. Vertical stretch. The vertical stretches affect x's? Nope. But they do affect what? Y. So let's see here. My y-intercept was at 1, 2, 3, 4, 5, 6. It's now at 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Crazy. It was at 6, it's at 18. How is that possible? I vertically stretched by a factor of what? 3. So my vertical stretch, when I put a number in front of there, it's not going to affect my x-intercepts, is it? So people will go and give me an equation and they don't solve for that vertical stretch. And they're like, it's fine, I have it. But it does affect your y-intercepts. It does affect your max and mins, doesn't it? It'll change some of them. So you still do have to solve for that vertical stretch every single time. Like when you did quadratics, you put in your vertex, you put in the coordinate, and you solved for the a, that a value in front. You were solving for the vertical stretch, you just didn't know. You just listened and you did what you were told. Okay? I want you to understand why. We need to solve for that vertical stretch every single time, because you're right, it is not going to affect our x-intercepts. But it will change our y's. It'll change our max and mins. It'll change every single point except for our x-intercepts. right? So we have to solve for that a value every single time. So with a quartic function, we can have at most how many x-intercepts? 4. We could have less, right? We have to have 4. With a quartic function, we need to have an x4 in our equation, correct? So if you have like an x2, you know you missed something. Something is wrong. So we have a quartic function. This is at the very back of that booklet. Very, very, very back. Last page. A quartic function with zeros to multiplicity 3. So I know I have x equals 2 multiplicity 3, and I have negative 5. X equals negative 5. Okay? So it's the very back page. So it also told us we have a y-intercept of 30. When we hear y-intercept, what should just happen? Every time you hear y-intercept. Yeah. X equals 0. We also know on a polynomial that our y-intercept is our constant if it's not in brackets, right? Because anything in factor form doesn't have a constant, you'd actually have to multiply those numbers out to check it. Okay? All right. These are our roots. To work them back, we have to work it back to here and get it to x equals 0, right? So we have x equals 2. I'm going to subtract it over, so I'm going to get x minus 2 equals 0. And then I have x equals negative 5. I'm going to add it over, so I'm going to get x plus 5 equals 0. And then I'm going to do y equals, I'm going to leave a little space here, and I'm going to go x minus 2, x plus 5, and people will say I'm good. I put my roots. If I FOILed that back, or I multiplied my x's in the front, that's an x squared, correct? It's not an x4, is it? What do I have to do to get that x4? Yes, I have to cube that factor. It's multiplicity of 3. It means there's 3 there. The only way there's 3 there is if I have 3 there. How do I show that? As a root, I write multiplicity 3. As an x-intercept, as a 0, I write multiplicity 3. As a factor, I cube it. People will forget to cube. But remember, your function, when you multiply it, should have x4, right? So here I would distribute my 3 and I get x cubed times x. So it's x cubed times x, x to the 4. Because we have the same base, we add exponents. Okay, now this is what everyone's going to forget. You're going to forget to find that a. You're going to forget to find that a. Now I'm going to tell you why my a has to be found. If I rewrite this one out, I'm going to rewrite it out down here. If I don't solve for my stretch factor, I have x minus 2, x minus 2, x minus 2, x plus 5. We agree? And I told you the fastest way to get the constant when it's in this form is to multiply all those numbers that are at the back. So I'd go negative 2 times negative 2 is 4, times negative 2 is negative 8, times 5 is negative 4d. Crap, it needs to be 30. So if you don't solve for the a, you're done. Right? You will forget to solve for the a. Please don't. Prove me wrong. I want to be wrong. I want every single person in here to not forget to solve for the a. So we have to put an a in here in front, and we need to find that stretch factor. Well, we have a coordinate, right? They have to give us a coordinate. They did. They gave us 0 and 30. How can we solve for a variable? In physics, we do it the same. When we solve for a variable, we have to be missing only that variable, correct? So I need to solve for a, I need to fill in x, and I need to fill in y. Wait a second, they gave me an x and a y. I can fill it in. So I'm going to do that. I'm going to get 30 equals a, 0 minus 2 cubed, 0 plus 5. So I'm going to get 30 equals a. This is going to be negative 8. I'm not going to skip steps to show you. Times 5. 30 equals negative 40a multiplied. Divide by negative 40. A equals negative 3/4. And then people will stop here. That's lovely that a equals negative 3/4, but have I written out an equation? They wanted me to write an equation. So I'm going to go y equals negative 3/4 x minus 2 cubed x plus 5. And now I actually have the equation. Okay? So not a hard thing to do at all, but people will forget to cube, and people will forget to solve for a. And remember, you should be able to plug this into your calculator after and see, do I have a y-intercept of 30? Do I have these x-intercepts that I said I have? If I don't, I messed up. What did I do to mess up? You could also check by filling it in here. You can go x times x times x times x. Okay, that's x to the 4, we're good. Negative 3/4 times negative 2 times negative 2 times negative 2 times 5. Ah, that gets me 30. I didn't mess up. Because you can check your constant in factor form. You just have to remember to multiply this negative 2 3 times because there's 3 of them. And if that's hard to imagine, just write it out 3 times and then multiply. Okay? I'm going to get you guys to try B, and then we're going to go to the big kahuna question on a separate sheet of paper. So a reminder that when it says constant term in one of these questions, I gave you the y-intercept, right? Just so fancy that they can say that. A quintic function, so that's degree 5. 0 equal negative 1, multiplicity 2. X equals 3, multiplicity 1, which I don't need to write. And x equals negative 2, multiplicity 2. So I'm going to get y equals a x plus 1 squared, x minus 3 by moving it over, x plus 2 squared. I need to plug in my x and my y. So I get negative 12 equals a 0 plus 1 squared, 0 minus 3, 0 plus 2 squared. Negative 12 equals a times 1 times negative 3 times 4. Divide by negative 12. A equals 1, because 1 times negative 3 times 4. So in this case, if you have forgotten to find the a, you would be lucky. One more before we do the big kahuna question. I'm giving you a cubic. X equals a half, multiplicity 2. And x equals 2/3. Y-intercept zero 12. All right. So we have to work backwards, right? So we have to multiply the 2 up first. 2x equals 1. Subtract the 1 over. 2x minus 1. This one we have to multiply our 3 up first. 3x equals 2. And then we have to subtract the 2 over. 3x minus 2 equals 0. So I just wanted to prove to you that these are the ones you make oopsies on, right? Most people are really good with like the x equals 3 because that's fast. These ones I get some crazy wonky answers. Okay? So we're going to get y equals a 2x minus 1 squared, 3x minus 2. And then I have to fill in xy. Could they just also bold? Like, could they give me a graph of, could they give me a graph of a polynomial and then bold another point on it? On the graph, and you use that point? Does it always have to be a y-intercept? No, it could be a coordinate. Be suspicious. When it's a graph and they're asking you for an equation of it on the diploma or on my unit test and a point is bolded, be suspicious that, hey, they probably want me to use that point. Okay, if there's a bolded point. Or if you're like, why is there one bolded point? And I just use the x-intercepts. I don't know. It's probably just there for randomness. It's not. It's for to solve the A. So maybe that'll be a hint. You'd be like, don't forget to solve for A. There's a bolded point. Why is it bolded? That's just strange and weird. Why did they give me this random point? It's not an x-intercept. Oh, solve for A. So we have 12 equals A, 2 times 0 minus 1 squared, 3 times 0 minus 2. The y-intercept is the nicest to get because all the zeros cancel. 12 equals A, negative 1 squared is 1, times negative 2. 12 equals negative 2A, divide by negative 2. A equals negative 6. But don't forget to rewrite the equation. Y equals negative 6. 2x minus 1 squared, 3x minus 2. So we now know how to draw graphs. We now know what graphs look like. We now know how we make our graphs. We know now how to make an equation of a graph, correct? Paper in front of you is what you're going to do for me. I want you to make a graph and determine an equation. With the following guidelines. Or parameters, as we would say in that. Quintic. Should I start with Quintic? That's kind of mean. Sure. Quintic, 3 x-intercepts, positive y-intercept. So all this happened. Worst recording. I always remember to press record. This is sad. I didn't. You're either going to have to go through once and then bounce and go through and bounce, or you could bounce, go through, come back down and bounce. Or a varying level. The thing you need to know is you need to have 2 bounces, 2 tangents, and a positive y-intercept, right? There's options, lots of options. I'm pretty sure not one of you picked the same option, right? It's very open-ended. Okay, so I picked this. I put my x plus 6 in, my x minus 2 in squared because it's tangent, x minus 4 in 2 because it's tangent, so there's a multiplicity of 2. And then I go 0 plus 6. This can be a really large number. So I'm going to get 10 equals a 6 times 4 times 16. What's 6 times 4 times 16? What's 24 times 16? Anyone? You would help me? I could do it, but I don't really want to. 384. So I do this and I have a 10 here. Probably going to be pretty ugly, isn't it? Guess what I like doing? Instead of a 10, what could I have made it be? I could have made it be 384 and then my A would be a 1. Good and bad. Good, my A is nice. Bad, I have a little 10 by 10 graph in front of me that I have to make a 384 approximate window. Probably not that great, right? So what I would do, what you could do, and this is also another hint, if you use smaller x-intercepts, these numbers don't get as big, right? Use smaller x-intercepts, those numbers don't get as big. If you square the smaller ones, like a -1 and a 1, boom, your number really doesn't get as big. So we can make educated, better decisions to make our numbers not so crazy. But you know what? I like this. I like this one. So we're going to divide by 384. And 10 over 384 is going to get me the exact same mark as a genius person who gets a nice one that doesn't look this stupid. Right? This person is not going to get any less of a mark as the other person, but the marker will be so much more proud of the person who maybe has like a 3 or something as their A. But they're not going to give you any different marks. Okay? So we go, yeah, we could do 5 out of 84 is 42, 150, 192. I like 10 better, but we can do it. Okay, so we'll have y equals 5 over 192. That's so pretty. X plus 6, x minus 2 squared, x minus 4. And then everyone boxes this and they're like, boom, my graphs match my equation. Look at that. Like, I random drew maxes and mins on there. Like, they are random, very, very random. I 100% think that when I type this in, this is not going to look the same as that at all. So then there I am in a conundrum marking this. Do I mark the graph and say, yes, they did perfect on the graph and they botched their equation? Or do I say, yay, they did 100% on their equation and they botched their graph? Because they don't match, right? So when you're done, go back and make them match. You have an equation now. You have a calculator in front of you. You can get all the max and mins and everything off of it, right? Five, you're going to help me here. Because I don't remember what it was. 5 over 192. Let's see if you guys remember. Alpha y equals, enter. 5 over 192. And then it was x minus 6, x minus 2 squared, I think. And then x plus 6. So these pluses, these were pluses. Come on, Lepp, grab a mitt. Get in the game. Talking, oh my gosh, grab a real mitt. Like, what am I doing? What is happening? Move over. X plus. I think I picked 4. Did I pick 4? Sure. Sure, it's going to look just like my graph. Zoom.
I think it was +2 that you chose.
Did I pick +2?
Your equation.
Well, let's see, after that, I don't remember. I had a +2, I just didn't write. I chose, yeah. Dang nabbit. My graph's really off. My graph's really off. That one's really off, so I just did some stupid stuff. Oh, this is a debacle of epic proportions. Ah! It's gone. So I'd be like, oh crap, that didn't work. And then I would go here and I'd be like, but do my x-intercepts work? Does my y-intercept have a positive y-intercept? Did my graph royally suck because I put the 2 as a positive? Yeah. So I would be like, dude, I don't care what I drew before. I would just be erasey, and no one would know the y's except you do because I recorded it and you watched it. And it's a problem, but I screwed up the factor and I wrote the wrong sign. It's a real problem. But now I would just go back and I would erasey, and I would redraw. Right? This is the key thing as to when you type it into your calculator after you get the equation, you'll at least catch mistakes. And I'd like to say that that was intentional, but it was not. That was just totally a royally screw up. But it's really easy to write the wrong sign, right? But did it rook me in the end because I checked it? No, I still would have gotten 100% on this test. On the test, but on this question, I would have got 100% if it was a one-question test. Because I would have went back and redrew it. And the person marking it, me, would have not known that me did that. You know, me, all doing the me things. And stuff and the things, right, Johannes? So does that make sense besides the screw up? because then I would go back and just redraw it, right? I still have my proper x-intercepts, and I still have my y-intercepts, and I would label those things. I would label my x-intercepts, I would label my y-intercept, and I would be like, man, good thing I typed that back in, because I royally sucked on that one, right? But in the end, I still would got 100% because I checked my equation with my graph. So I can't tell you how much. You have to do that. Fair game question though, right? Hard question. It's not super easy, but it's not ridiculously hard either. You just have to start. Sometimes it's just like you start and then you see. And then if you could go, wait, that's going to be a really ugly fraction. Well, if I would have just made my y-intercept be 20, this would be better. Or hey, I shouldn't have picked such large x-intercepts. Smaller ones would have been better. Because then it'd be easier to draw, my A would be better. Sometimes having a weird fractional A, is that the end of the world so that your graph isn't like so hard to draw? No, have a fractional A, that's okay. Spread your x-intercepts out. Like it's not a big deal. It doesn't have to be like a 3 or a 2 or something. Okay? Your homework.